Here's problem 12.5. An 800 Newton billboard worker stands on a 4-meter scaffold weighing 500 newtons and supported by vertical ropes at each end. How far would the worker stand from one of the supporting ropes to produce a tension of 550 newtons in that rope? Let's start with a free body diagram. Here's our scaffolding. And we know we have 2 ropes on it, so there's going to be, let's call it tension 1 and rope 1 on the left, and let's call it tension 2 and the rope on the right. We know the scaffolding has weight, and that's acting at its center of mass, so the weight of the scaffolding is 500 newtons right at the center of the mass, right there. And then we have a worker somewhere standing on this. We don't know where the worker is. And the worker has weight, and the weight of the worker is 800 newtons. We're going to assume the worker is some distance x from the left-hand side. Actually, let's put that in red. And hence, we're going to use that side as the side which has the tension of 550 newtons. So we're going to say that tension number 1 is 550 newtons, and we want to find out what x is for this worker. Alright, so we know 3 of the forces. We don't know tension 2, and we want to find x. So one way to approach this problem is to set up a torque diagram, and as we're choosing which axis we're going to use, 2 good points to choose would either be A or B. Now if I choose A, I'll eliminate T1 from consideration because line of action goes through A, but that's not a good thing because I already know what T1 is, so I want to use that in the problem. So I'm going to choose point B for my axis because I don't know what T2 is. If I choose B, I eliminate T2 from consideration in terms of torques because it has a moment arm of 0. So now in terms of a torque diagram, this situation about point B looks like this. I have a T1 force that has a moment arm of 4 meters. I have a weight force of 500 newtons that has a moment arm of 2 meters away from point B. And then I have a person standing there. And what is his distance from point B? Well, he is x distance from the left-hand side, from point A, and the whole scaffold is 4 meters long, so the distance from point B is going to be 4 minus x. Alright, so that'll be our moment arm for the weight of the person, which was 800 newtons. Okay, now looking at this, we have 2 of these forces causing torques about point B that are going counterclockwise. This is trying to make this rotate counterclockwise about B, and so is the weight of the man. So both those torques are actually going to be positive torques by the right-hand rule. If you curl your fingers in a counterclockwise direction, your thumb will point out of the page, which would be a positive z direction. And the T1 force is trying to make this thing rotate clockwise, which would be a negative torque. If you curl your fingers in that direction, your thumb will point into the page, which would be a negative z direction. So we have 2 positive torques, 1 negative torque. The summation of all the torques about B should equal 0 because the thing is not rotating at all. And what we have is we're going to have 2 meters times 500 newtons plus 4 minus x meters times 800 newtons minus 4 times T1, which is actually 550 newtons. I probably could have put that in right away. So we have 0 is equal to 1,000 plus 3,200 minus 800x minus 4 times 550 for T1. Let's solve this for x. So we have 800x is equal to 4,200 minus 2,200 for 4 times 450. So x is going to equal 2,000 divided by 800. And that is equal to 2.5. So our distance x is 2.5 meters from the cord that has the tension of 550 newtons, or from the rope that has that tension of 550 newtons. So that's our answer. If the person stands 2.5 meters from that end, it'll cause a tension of 550 newtons in that rope. Final answer.